It's important to approach electrical code interpretations with careful consideration for safety and compliance. Several potential problems can arise from misinterpreting or misapplying the National Electrical Code, or NEC. Firstly, consider the risk of fire hazards. Improperly sized conductors, inadequate overcurrent protection, and loose connections can all lead to overheating and potentially ignite surrounding materials. For example, if you're using a 14 American wire gauge wire for a 20 amp circuit, it's a recipe for disaster. The code specifies appropriate ampacities for conductors, and exceeding these limits can cause insulation to melt and create a short circuit. Secondly, there's the danger of electrical shock. Exposed live parts, damaged insulation, and lack of proper grounding can create pathways for current to flow through a person's body. Ground fault circuit interrupters, or GFCIs, are crucial in wet locations like bathrooms and kitchens to quickly de-energize a circuit if a ground fault is detected. Thirdly, equipment damage is a significant concern. Voltage fluctuations, harmonics, and improper wiring can damage sensitive electronic equipment and appliances. Surge protection devices, or SPDs, can help protect against voltage spikes, and proper wiring practices can minimize harmonic distortion. Fourthly, consider code violations and penalties. Failure to comply with the NEC can result in fines, project delays, and even legal action. Electrical inspectors are responsible for ensuring that installations meet code requirements, and they can issue correction notices for any deficiencies. Fifthly, there's the issue of energy inefficiency. Using outdated or inefficient equipment and wiring practices can lead to higher energy bills and increased environmental impact. Energy-efficient lighting, appliances, and smart home technologies can help reduce energy consumption and save money. Sixthly, improper grounding can lead to a multitude of problems. Grounding ensures a safe path for fault current to return to the source, minimizing the risk of electrical shock and equipment damage. Grounding electrodes, bonding jumpers, and equipment grounding conductors are essential components of a properly grounded system. Seventhly, arc flash hazards are a serious concern in industrial and commercial settings. An arc flash is a dangerous electrical explosion that can cause severe burns, injuries, and even death. Arc flash hazard analysis, personal protective equipment, or PP, and arc flash-rated equipment are necessary to mitigate these risks. Eighthly, consider the problem of voltage drop. Excessive voltage drop can cause equipment to malfunction, lights to dim, and motors to overheat. The NEC specifies maximum voltage drop limits for branch circuits and feeders, and it's important to size conductors appropriately to minimize voltage drop. Ninthly, there are concerns regarding inadequate wiring capacity. Overloading circuits can lead to overheating, nuisance tripping of circuit breakers, and potential fire hazards. It's important to calculate the load on each circuit and ensure that the wiring is adequate to handle the demand. Tenthly, improper use of flexible cords and extension cords can create safety hazards. Flexible cords are intended for temporary use and should not be used as permanent wiring. Extension cords should be properly sized for the load and should not be overloaded. 11thly, the issue of tampering with electrical equipment is a significant problem. Unauthorized modifications to electrical equipment can compromise its safety and performance. Only qualified electricians should perform electrical work, and all modifications should be done in accordance with the NEC. 12thly, consider problems associated with using non-listed or counterfeit electrical products. Counterfeit electrical products may not meet safety standards and can pose a serious risk of fire, shock, and equipment failure. It's important to use only listed or certified electrical products from reputable manufacturers. 13thly, consider the complexities of working with different types of wiring methods. The NEC specifies different wiring methods for various applications, and it's important to choose the appropriate wiring method for the environment and the type of load being served. For example, using non-metallic sheathed cable in a wet location can lead to corrosion and electrical shock hazards. 14thly, consider the impact of environmental factors on electrical installations. Temperature, humidity, and corrosive environments can all affect the performance and lifespan of electrical equipment. The NEC specifies requirements for protecting electrical equipment from these environmental factors. 15thly, consider the importance of proper labeling and documentation. Clear labeling of electrical panels, circuits, and equipment is essential for safe operation and maintenance. Documentation of electrical installations, including wiring diagrams and load calculations, is also important for future reference. 16thly, the NEC changes every 3 years, so staying up to date with the latest code requirements is crucial for electrical professionals. Failure to comply with the latest code can result in violations and potential safety hazards. 17thly, it's important to understand the difference between prescriptive and performance-based code requirements. Prescriptive requirements specify exactly how something must be done, while performance-based requirements specify the desired outcome but allow for flexibility in how it is achieved. 18thly, consider the role of continuing education in maintaining electrical competency. Electrical technology is constantly evolving, and continuing education is essential for electrical professionals to stay current with the latest trends and best practices. 19thly, it's crucial to have a thorough understanding of electrical theory and principles. A solid foundation in electrical theory is essential for understanding how electrical systems work and for troubleshooting problems. 20thly, effective communication skills are essential for electrical professionals. Communicating clearly with clients, contractors, and inspectors is crucial for ensuring that projects are completed safely and successfully. 21st, the proper selection and installation of overcurrent protection devices, like circuit breakers and fuses, is critical for preventing overloads and short circuits. Using the wrong type or size of overcurrent protection device can result in equipment damage and fire hazards. 22nd, be aware of the specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. The NEC has different requirements for each type of occupancy based on the specific hazards and risks associated with each. 23rd, understand the importance of coordination between different trades such as electricians, plumbers, and HVAC technicians. Poor coordination between trades can lead to conflicts and potential safety hazards. 24th, consider the impact of renewable energy sources such as solar and wind power on electrical systems. The NEC has specific requirements for the installation of renewable energy systems, and it's important to follow these requirements to ensure safety and reliability. 25th, be aware of the potential hazards associated with working on energized electrical equipment. Working on energized equipment should be avoided whenever possible, but if it is necessary, proper safety precautions must be taken, such as using insulated tools and personal protective equipment. 26. Consider the importance of regular maintenance and inspection of electrical systems. Regular maintenance and inspection can help identify potential problems before they become serious and prevent costly repairs. 27th. Be aware of the potential hazards associated with underground wiring. Underground wiring can be damaged by digging, corrosion, and other factors. It's important to locate underground wiring before digging and to protect it from damage. 28th, consider the impact of the electromagnetic interference, or EMI, on sensitive electronic equipment. EMI can disrupt the operation of electronic equipment and cause it to malfunction. Shielding and grounding can help mitigate the effects of EMI. 29th, the proper installation of lighting fixtures is essential for providing adequate illumination and preventing fire hazards. Lighting fixtures should be installed in accordance with the NEC and the manufacturer's instructions. 30th, consider the importance of proper ventilation for electrical equipment. Electrical equipment generates heat, and proper ventilation is necessary to prevent overheating and equipment failure. 31st, be aware of the potential hazards associated with working in confined spaces. Confined spaces can contain hazardous atmospheres and other dangers. It's important to follow proper safety procedures when working in confined spaces. 32nd, consider the impact of aging electrical infrastructure on safety and reliability. Aging electrical infrastructure can become unreliable and pose a safety hazard. It's important to inspect and upgrade aging electrical infrastructure to ensure safety and reliability. 33rd, understand the requirements for emergency power systems, such as generators and uninterruptible power supplies, or UPSs. Emergency power systems are essential for providing backup power during power outages. 34th, be aware of the potential hazards associated with working with high-voltage equipment. High-voltage equipment can be extremely dangerous, and only qualified personnel should work on it. 35th, consider the importance of following lockout/tagout procedures when working on electrical equipment. Lockout/tagout procedures are designed to prevent accidental energization of equipment during maintenance and repair. 36. Be aware of the potential hazards associated with working in hazardous locations, such as areas with flammable gases or dusts. Hazardous locations require special electrical equipment and wiring methods to prevent explosions and fires. 37th, consider the impact of cybersecurity on electrical systems. Cybersecurity threats can disrupt the operation of electrical systems and cause widespread damage. It's important to implement cybersecurity measures to protect electrical systems from cyber attacks. 38th, understand the requirements for fire alarm systems. Fire alarm systems are designed to detect fires and alert occupants of a building. 39th, consider the importance of proper documentation of electrical installations. Proper documentation of electrical installations, including as-built drawings and operating manuals, is essential for future maintenance and troubleshooting. 40th, consider the necessity to properly apply the directing factors according to NEC Table 310.15 when multiple current-carrying conductors are in a raceway. Failing to apply these directing factors can cause the wire insulation to overheat and potentially cause a fire.